Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Lunar Horizons. China's bold vision for a permanent moon base in the new space race. China's lunar exploration program has solidified its position as a cornerstone of global space exploration, blending cutting-edge technology, geopolitical strategy, and scientific ambition into a cohesive vision for the moon's future. The landmark success of the Chang'e 6 mission in 2024, which returned the first deep subsurface samples from the moon's south pole, has redefined humanity's understanding of lunar resources and cemented China's role as a leader in the new space age. As the world looks ahead, China's ambitions are crystallizing around the International Lunar Research Station, ILRS, a bold initiative to establish a permanent, collaborative base near the resource-rich lunar South Pole. This project, framed as both a scientific endeavor and a strategic asset, positions China at the forefront of a global race to harness the moon's potential, setting the stage for a decade of unprecedented activity in space. The Chang'e 6 mission, completed in late 2024, stands as a triumph of engineering and diplomacy. By landing in the rugged terrain of the South Pole's Aitken Basin, the mission confirmed the presence of water ice trapped in permanently shadowed craters, a discovery with profound implications for sustaining human life on the moon. The return samples, now being analyzed by international laboratories, contain not only water but traces of methane and ammonia, compounds that could revolutionize in situ resource utilization, ISRU. These findings have galvanized support for China's lunar agenda, both domestically and among its international partners. In 2025, the focus has shifted to leveraging this success into tangible progress for the ILRS, with engineers refining technologies for ice extraction, habitat construction, and energy production. The Keiqiao-2 relay satellite, operational since 2024, remains a critical asset, enabling uninterrupted communication with future missions to the moon's far side and South Pole, regions once deemed too remote for sustained exploration. In this year, China will be finalizing preparations for Chang'e 7, a mission slated for launch in 2026 that represents the most complex robotic endeavor in lunar history. The mission's architecture, an orbiter, lander, rover, and a revolutionary hopping probe, is designed to explore the moon's south pole with unprecedented granularity. The orbiter will deploy advanced radar and spectrometers to map subsurface ice deposits, while the lander and rover will test prototypes for converting water ice into breathable oxygen and hydrogen fuel. The hopping probe, a technical marvel, will use compressed gas thrusters to leap between shadowed craters, sampling ice from multiple sites to assess its purity and distribution. This mission is not merely scientific. It is a strategic step toward identifying optimal locations for the ILRS, ensuring that the base's infrastructure is built where resources are most abundant and accessible. Following Chang'e 7, the Chang'e 8 mission, planned for 2028, will pivot to large-scale manufacturing and construction experiments. Central to its objectives is the demonstration of 3D printing technologies using lunar regolith. By sintering the moon's soil into bricks, radiation shields, and even solar panels, China aims to prove that habitats and infrastructure can be built from local materials, drastically reducing the need for costly Earth-launched supplies. Chang'e 8 will also test autonomous robotics for assembling prefabricated modules, a precursor to the ILRS's modular design. These missions, unfolding over the next 3 years, are the robotic vanguard of China's lunar strategy, proving technologies, mitigating risks, and laying the groundwork for human arrival. The International Lunar Research Station, ILRS, is transitioning from concept to reality. Co-led by China and Russia, with partnerships extending to nations like Pakistan, the UAE, and South Africa, the ILRS embodies a vision of the Moon as a shared scientific and economic frontier. The station's development is structured in phases, with Phase 1, 2025-2030, focused on robotic precursor missions. Key to this stage is the deployment of the Guangwei Solar Farm, a network of photovoltaic panels positioned on sunlit crater rims to provide near-continuous power for early infrastructure. Autonomous robots, launched via China's Long March 8 rockets, will begin grading terrain, laying foundations, and testing small-scale water extraction systems. By 2027, the first 3D printed structures, radiation-shielded storage depots and landing pads, are expected to rise from the regolith, marking humanity's first permanent infrastructure on the Moon. Concurrently, China is advancing its crewed lunar ambitions. The Long March 9 Super Heavylift rocket, now in advanced development, is scheduled for its maiden flight in 2030. This rocket, capable of delivering 50 metric tons to lunar orbit, will transport the ILRS's core modules, including crew habitats and laboratory units. In parallel, engineers are refining the next-generation crewed lander, designed to ferry takenauts from lunar orbit to the ILRS site. Biomedical research is underway to address the challenges of prolonged lunar stays, with the Huigong 3 facility in Beijing simulating year-long missions in closed-loop ecosystems. By 2030, China aims to land its first crew at the ILRS, beginning an era of continuous human presence on the Moon. China's progress is underpinned by breakthroughs in robotics, AI, and energy systems. The Xingzhe Pathfinder rover, set to launch with Chang'e 7, exemplifies this innovation. Equipped with swarm intelligence algorithms, Xingzhe can collaborate with other robots to perform complex tasks, repairing equipment, laying power cables, or constructing solar arrays, with minimal human oversight. Advances in nuclear power systems are also critical. Compact fission reactors, tested in remote regions of Xinjiang, are being adapted for lunar use to supplement solar energy during the Moon's 2-week nights. Internationally, China is positioning the ILRS as an inclusive alternative to the U.S.-led Artemis Accords. By offering partner nations access to lunar data, shared infrastructure, and payload slots on missions, China is cultivating alliances with countries historically excluded from space superpower collaborations. European nations like France and Italy, though cautious of geopolitical tensions, are engaging in scientific partnerships, contributing instruments for Chang'e 7 and ILRS modules. This diplomatic strategy not only diversifies funding and expertise but also legitimizes China's vision of a multipolar space ecosystem. The ILRS's rise occurs against a backdrop of escalating rivalry with the United States. Both nations are targeting the lunar South Pole, drawn by its water ice and strategic value. NASA's Artemis Base Camp and China's ILRS exist as parallel projects, separated by politics but converging geographically. The risk of disputes over resource access or landing sites looms, exacerbated by the absence of clear international laws governing lunar activity. While China advocates for UN-mediated frameworks to manage these tensions, the U.S. Congress's Wolf Amendment, which prohibits NASA from collaborating with China, complicates dialogue. Private companies add another layer to this competition. SpaceX's Starship and Blue Origin's Blue Moon landers are vying to support NASA's efforts, while Chinese firms like CurioCity and CASC are developing reusable lunar landers and cargo systems for the ILRS. Beyond geopolitics, the ILRS promises transformative scientific returns. Astronomers anticipate deploying radio telescopes on the Moon's far side by the 2030s, free from Earth's electromagnetic interference, to study the universe's dark ages and detect faint signals from ancient stars. Biologists plan to study extremophile organisms in lunar soil, probing the limits of life in low gravity and high radiation. For industry, the Moon's rare earth metals and helium-3 deposits are tantalizing, though extraction remains a distant prospect. In 2025, China is prioritizing ISRU technologies that convert ice into rocket fuel, a capability that could slash the cost of deep space missions. The ILRS, in this context, is not just a research base but a prototype for a future lunar economy, one where fuel depots, mining robots, and 3D printed factories enable sustainable exploration of the solar system. As China advances its lunar agenda, ethical questions proliferate. How will the Moon's environment be protected from contamination? What safeguards exist to prevent conflicts over resources? Chinese academics are spearheading discussions on lunar governance, proposing frameworks that balance exploitation with preservation. Culturally, the Moon holds deep significance in China's heritage, symbolizing unity and immortality in folklore. State media has woven the ILRS into narratives of national rejuvenation, portraying takenauts as heirs to the mythical Chang'e, a fusion of tradition and modernity that resonates with public sentiment. As 2025 unfolds, China's lunar program stands at an inflection point. The ILRS, once a distant vision, is now a tangible project with robotic missions underway, international partners on board, and technologies maturing rapidly. The challenges ahead are formidable: technical hurdles, political friction, and the sheer cost of sustaining a presence on an airless, radiation-bathed world. Yet the potential rewards, scientific discovery, economic opportunity, and the prestige of leading humanity's return to the Moon, are equally vast. For China, the ILRS is more than a base. It is a statement of intent, a declaration that the 21st century's space race will be defined not by fleeting flags but by permanence, collaboration, and the audacity to transform the Moon into a stepping stone for the stars. In this new era, the Moon is no longer a silent neighbor but a contested, collaborative, and increasingly familiar frontier, a testament to humanity's enduring drive to explore, innovate, and transcend.